Homework.
No, I can't have it because
Cool.
that's fine.
All right, it's week 7. I'm gonna go over the exam for a little bit, and then we're gonna just do homework for the rest of the time.
Are we going to put the exam back in physical part?
Yeah, I'll give it back at the end of this discussion. The grade should be up on CCLE already. All right, so midterm 1A, it was asking what's surprising. All you had to really say was a surprising number of strains would be more than just kind of a random sort of assortment. So if it's greater than the population frequency, when you divide out by the total number, you got all the points for that one. So this is worth 10 points because it was kind of just the hypothesis testing in general. Usually the questions would be 5 points unless they took a lot of effort for them. So this was 10. It was just basic hypothesis testing. Most of you got it right. The next part says, I don't have the exam in front of me, but I was expecting some sort of p-value sort of equation. So as long as you gave me something that looked like a p-value kind of equation, it's probably good. Okay. The next one asked what model you should use. Well, we only talked about 2 models, and it was either binomial or the Poisson distribution. But you can't have more strains mutated than the number of strains to begin with. So if it's limited by a number of strains or a number of genes or a number of people, it's the binomial distribution. If it's not limited to a function like that, then it's the Poisson distribution. Okay, so that was one. Oh, all right. This one was asking about multiple testing. So if you gave any sort of Bonferroni correction answer or any sort of p-value adjustment based on how many times you do the test, which is how many genes are in your whatever this n was, that was all I was looking for on this one. Some sort of multiple testing. If you talked about that, you probably got most of the points. Okay. So the first one was hypothesis testing. This one is more just Bayesian statistics. So what Dr. Lee was looking for was the posterior odds ratio, but if you gave any attempt at an odds ratio that looked like an odds ratio, I probably gave you most of the points. But we were looking for this, and the most important part is it takes into consideration the population, carrier rate. So if you tried to set up an odds ratio and it had some sort of population rate in there, you probably got most of the points. This one was, the whole idea was kind of just human genetics. Women have 2 X chromosomes to give to their kids. Guys don't contribute any X chromosomes. So you know it came from your mother if it's an X chromosome. And if she's a carrier, it's a 50-50 shot. So that was the first part. And if you know your mother's not a carrier, then you can't have any genes that are mutated passed on to your son. So 50-50 shot or 0% chance of no mutation passed on. That was what was being asked there. Okay, this one was, you took your part from part A, you plugged in the numbers from part B. If you did an equation incorrectly in part A and numbers incorrectly in part B, as long as I saw you kind of knew what was going on, you probably got most of the points. Okay. The third one was about UPGMA, and it says what's the most important assumption. We were looking for molecular cost. So constant mutation rate correlates to distance on the tree. I'm doing this kind of quick so you can just watch the video and we can spend the whole time talking about homework. The biggest question was actually doing the tree. I tried to make it pretty even numbers and pretty simple, but if you were doing it wrong, then they probably came out to hard numbers. So I apologize, but this was the tree. If you really want to know the answer, we can spend some more time at the end of this class or in office hours, but the tree ended up looking like this. This was 15 points because it was a lot of work for you guys. But if you did it mostly right, you got most of the points. So orthologs versus paralogs. Orthologs are separated by speciation events. Paralogs are separated by duplication events. And typically orthologs have similar functions. That's the assumption. So if you talked about that, probably got most of the points. how do you do this computationally? It takes the idea that you have a full genome of genes to look at. You can look for the best hit, and if the best hit is in both directions when you search from one genome to another genome or the other genome to the first genome, that's a reciprocal best hit, and that's just what we were looking for. So we assume that orthology is implied by reciprocal best hits, and they form clusters, which was this part. A lot of people only, this is a matrix representation of just listing it out, but if you didn't give me the groups, because these all kind of form two separate clusters of groups, then I took some points off, but we were hoping for groups of orthologs, and I could show that on the board later too if you want.
Were the two groups paralogs to each other? Or?
Yeah. They were. Yeah, sorry I'm going kind of quick, but I just want this like for the video, and then you can go back and watch the video and we can talk about homework. The last one kind of came from left field, the phylogenetic profile, but if you remember this slide from the lecture, whatever, yeah, so it's the idea that genes are inherited together if they're expressed together or function together. So that would be like a pathway in biological systems. Or so you look at different species, how these genes get inherited between the species. That's kind of the basics of it. You can go back and look at the slides if you want to know the rest of it. Okay. Do you guys agree we should spend time on homework, or should I go talk about exams? Homework. Okay. Did you guys see the videos I sent out? I guess they're kind of useful, but we'll see. Do you guys want to go through a dynamic programming example, or did the video kind of do that? I'm getting some no's. Yes or no?
We'll go through this anyway.
Okay. For the people that did watch the video and stuff, did the idea kind of make sense? Can we kind of just do this kind of quick? Okay. So there's a whole big mathematical reason for why putting one sequence on the bottom of a grid and one sequence on the side of a grid might be useful. But let's just assume that that's correct, and this is the best way to align two sequences. So we talked about a scoring function where if at any two rows and columns, if it's a match, it's 5 plus 5 points. If it's a mismatch, it's minus 3 points, but that's not as bad as just skipping it completely, so that's a gap. So we're talking about this kind of global alignment algorithm. So you have to align every letter down here to every letter up here. And that's probably not what you're looking for in biology, but it's kind of the easiest example to go through these types of things. So we start in this corner, and this is assuming we don't align anything to anything. That's just the starting point. And it has to end with the end of the two sequences up here. So there's kind of two situations that can happen. It can be in a gap, or it can be an alignment. And the alignments are scored one of two ways. So just to show an example of what an alignment is, if both of your sequences start with the letter A, that seems like a pretty good match to me. We're kind of getting ahead of ourselves. So there's a gap here and a little space here because you can always just not align the sequences at all. So if you followed the path on the bottom row, it would be A, G, G, T, A. Let's say that's your first sequence. And when you do sequence alignments, if you saw the blast from the homework, you can see like if you skip something or a gap, you can put a dash, and that's like a skip. And then we can align A, C, G, C. So this is a perfectly valid alignment in terms of the computer, where you can align something to something else by just saying skip the first length of it and then don't actually align anything. But if you wanted to look for homologous genes and your program spit out this, that's stupid. You wouldn't want that. So technically you can represent it by filling out, there's a gap here, a gap here, a gap here, a gap here, and a gap here. Does that kind of make sense? So on the matrix, there's a gap here, and it's minus 4 points, and then minus 8 points, and then minus 12 points. Math is hard. And also, you can look at this side where you skipped the fourth from last, third from last, second to last, and first from last. So what that means here is, in the videos I sent out, they talk about why the directions of the arrows are the way they are. But it's really just for tracing it back at the end where you pay attention to the arrows. Good, that's not right. Okay. So if we were to use this example up here, the alignment score would be minus 20 for this whole alignment. That's a pretty bad alignment if you're trying to get a number above 0. So yeah, you can do an alignment like this, but just looking at the numbers right away, it's terrible. But you need somewhere to start with. So the first thing you look at is what's the best number you want in this box? Because you can only really work with boxes where you know what's below it, to the left of it, and to the bottom left of it. So that's why we start in this corner at 0. We do know that A versus an A is like a good alignment. So without even looking at the other ones, this one is plus 5. If we wanted to automatically use this alignment where it's skip A first, then that would be represented by going straight up, I think. It's one of the two. Or the other one would be skipping it on the other side. But, okay. So the best way to align this so far, I would think, is they both start with the letter A. I think you guys would agree. Okay, so that's a match. That's good. That's a diagonal. Now we have to fill out the rest of this. I don't want to do the math in my head, so 4, C and A doesn't match up, so the next best one is a gap, and that's going to be plus 1, because plus 5 minus 4 is equal to plus 1, but minus 4 minus 3 would have been 7. So the reason we don't go from already skipping the first A to aligning A to C, which is these two, is because it's just a lower number than that one. Okay.
Why would you just mismatch it if mismatch is only minus 3 and gap is minus 4?
Because you're starting with a base of minus 4. So you already threw out this A, and you already kind of screwed yourself over. But now you already screwed yourself over, and it gets even worse because it's a mismatch. So, do you guys want me to keep going with this? Okay. Towards this corner, it gets kind of easy because it starts at minus 8. Nothing we do is going to really get to minus 8 just from matches or mismatches. So, on this one, we go from plus 1, we do a gap to minus 3 because, my handwriting's terrible. Okay. Whatever, yeah. So, we can do another gap just to bring us to minus 7. But what this is saying is none of these are probably going to be the optimal path. So here, we have a plus 5. We have a minus 4 over here. And even if we mismatch A to G, it's still going to be a minus 7, just like it would have been over here. But if we do a gap from a good alignment, then it's only a plus 1, like this corner. And if you do the math on all the rest of these, it turns out that this is minus 3, because plus 1 minus 4 is minus 3. Up here is minus 7. The only one that's kind of tricky is this A. Wait, that's not even right. Okay, never mind. And then you can do another gap up here with a minus 11. So if this idea kind of makes sense, I'm just going to fill in the rest, and we can talk about the second part, which is like the backtracking part of it. So plus 5 is pretty good. You can do a mismatch. It's 5 minus 3, so you get plus 2. And then G to G is a match. So from this, you can get plus 6. And then there's nothing you can really do here but take a gap, so this is plus 2. Up here, the best one is to take a gap, and now it's minus 2. I think there's 2 paths here, according to my notes, and now that's minus 6. So minus 3 is minus 6, and minus 2 minus 4 is also minus 6. So this one you can do either, and it doesn't really matter. Whatever you pick is going to be right for the solution. And then up here, once you kind of get stuck in this sort of situation, it happens across all the columns. So up here it's minus 10, whether it's minus 7, minus 3, or minus 6, minus 4. They both go up to 10. This is a match, G to G, so it's plus 7 from plus 2, so that's really good. But here you have to take a gap, so that's plus 3. And here you do it again, so that's minus 1. If you want to go this way, you just take another gap, that's plus 3. Usually if it's not a match, they kind of mirror the diagonal a little bit, but it really depends. Okay, here we can take a mismatch, so it's plus 4. And then because it's plus 7 minus 3, because C doesn't match up to T. And then either way you go up here, it's going to be a 0. Because plus 3 minus 3 is 0, and plus 4 minus 4 is also 0. But 0 is higher than minus 1 minus 4, which would be minus 5. So it ends up with being 0. It's not great, but okay. So from here you can take 2 paths coming out of the end point. I'm just going to go, I'm going to take the diagonal, and then I'm going to go up. And then I'm going to just take the diagonal all the way back to the beginning. So here there's 2 options. I picked the mismatch. Here there's only 1 option. Here there's only 1 option, 1 option, 1 option, all the way back to 0. So that was kind of quick, but you just go the opposite direction of the arrows, which is why sometimes when people write this, they do the arrows in the other orientation. So it's either unintuitive when you're making the matrix, or it's unintuitive when you're trying to backtrack it. But I think doing the arrows point in the direction as you're making it, I think is a little easier to understand. So what does this alignment mean? You have to start from the back of it. So starting at our last point, we said it was a mismatch alignment. So let's put this sequence on top and this sequence on bottom. If it's a mismatch alignment, there's an A on top and a C on the bottom, because this C and this A, that's the row and the column of the alignment. This one, we say we go down from here. So going down just says we don't use this T at all. So the down arrow or the up arrow, whichever way you're looking at it, is a T on the top alignment, but a gap, because it's a straight down. And then the rest of them is just complete matches all the way through. So whether it's a match or a mismatch, you get a G matched with a G, that's good. A G matched with a C, not so good. But because it's in the middle of 2 matches, it's probably the best way to go. So on the backtracking, you start from the top right, and you kind of just point to where the arrows in the other directions were. So what would have happened if we took the up arrow instead of the diagonal arrow? That would say we don't use the A in the beginning. So the A is here and a gap is here. Did I not write that? This would have been a diagonal. Okay. So it's either you take a diagonal and do a gap and then just go straight down, or this way, it's down and then all the way to the origin. So there's 2 alternate alignments that these can take, and it's really just saying where do we stick this T? Because the G matches with a G, the G matches with a C over here, even though it's a mismatch, and the A matches with an A every time, because that's the only path. So even though there's 2 alternate paths on the top corner, it kind of just means a similar alignment. You either said you don't match up your A with anything, or you don't match up your T with anything, because neither A nor T match up with C. So you can either skip the end or skip the middle. But okay, that was a kind of really quick way to go through that. Are there questions for that? I mean, you're kind of just looking at each box. You have to start from the bottom left box and only do the sides, and then you can start moving up one diagonal, and then you have to do the sides. And you keep filling out this table until you can start backtracking it. So maybe watch the video where in 2013 Dr. Lee went through this, and maybe it makes a little more sense this time around, and that might help with the homework. Did that kind of clear this up, or is it still kind of fuzzy with you guys? Okay, I got a shrug and then no answers. So come to my office hours if you want to go through this really slowly, but now we only have like 25 minutes left, so let's go through. All right, one of these, there's 3 functions you have to write, so I sent out some videos on functions. Usually a function in programming just means we're going to take code that we already have and we're just going to put it behind like we're going to not worry about the code, but just say every time we want to get the shuffled scores, this is posted, you don't have to take a picture of this. Okay, well there's 3 functions. One of them says run blast, but in the homework, you already have the code to run blast. Where did that go? Okay, whatever. Okay, so like as a hint, I'll tell you what you're going to be putting in the 2 functions. Where is it? Okay, so the first function that says run blast, you already do the work in the code that you're pasting into it. So you first have to import these 2 modules, you set up your blast command, and then later they tell you there's a couple extra things you stick in here. And then you do this this thing that tells you to actually run blast, that's all this line means. And you give it a sequence, and you also just tell it to run it down here also. But what you want to get out of it is this standard out part over here. Yes?
When I try to do this, when I get down to the part where it says mashed up, I get this error that tells me like root is not a defined thing.
Over here?
Yeah.
That's strange. We can look at it later.
Okay.
It worked when I did it, so it's...
I tried it from the beginning too, like I started over, I don't know.
Yeah, I don't know why that would happen. So if you watch the videos on functions, it's pretty much you just take code that you already use, and I'm pointing as a hint, and then you put it into a function so you can use it later. But if you want examples of that, we use some in the first homework. But I'm also going to send out, or I also already did send out, I think it's pretty hard for you guys to do that and try to write your own function for this last bit. So when you talk about this whole get shuffled scores, it requires more programming than I thought should be required in this class. So I'm just sending out the function for this. You guys have to figure out how to open up the text editor and put it in your own myhomework5.py file. But if you have really hard problems with it, come to my office hours. But yeah, I'm going to show you an example of a function for this one, and maybe that should make the other ones easier. We can actually go through it here, and I don't have anything after this, so I'm just going to go through this real quick, and then you guys ask your questions. Okay, so the first part of defining a function is just the word def, which means we're going to define a function. And you can put any name you want here, but in the homework we told you to use get shuffled scores. And if you give it any variables or any lists or anything, you have to put it in the parentheses, like we've seen before with functions. So without even looking at the code, we can just say we want a function that takes a sequence, it shuffles it, gives you the scores, and it does this n number of times. So in the homework we say use n of 1,000. When you're testing it on your own, I would definitely tell you to give it like a lower number, just so you know if it stops or finishes at all. But so it's just get a sequence, shuffle it, get the score that many times. So the first thing we do, just like in the homework, we define when you have like a word or a bunch of letters in programming, that's called a string of letters. So you can convert your string of letters into a list of letters. And the only reason you do that is because the randomization library only looks at lists. So that's the only reason we're doing this. We're converting our sequence, which is a string of characters, and we convert it to a list of single-digit characters. We want, at the end of this, we want a list of scores. So we just have to set up an empty list. When you do the square brackets, that means you're setting up an empty list. And then I sent out a video for it, but it's kind of a hard idea. If you want to do something over and over and over again, for instance, n number of times, in programming you just use what are called loops. So there's different types of loops. There's a for, F-O-R, not the number for loop. And that just says, we've kind of used it already, but for some variable in a range of variables, do something with it. So in this one I say, for loops in the number of loops that you want from the function, do something. And we can call this whatever. In this function I don't even use the variable called loops, but it just says do this many times. And so what do you do that many times? You shuffle your sequence, you turn it back into a string, or you just join the sequence back together. That's just programming speak for give me a randomized sequence. As a hint, you have these two other functions that you need to make. You already have the code for running BLAST, and it should output the BLAST report that you look at. So this function would take in the sequence and the BLAST report, and it gives you that. And then you just want the top sequence. So we use this other function, get top score, from the BLAST report, and we just, this is the hard part why I thought it was kind of more complicated than you guys have to deal with. But you can just append stuff to the end of a list. If you want to stick something at the end of the list, you just put append, that's the word for it, and it just puts that element on the end of the list. So if you have a bunch of students in a class and they all have grades and you have a big list of student grades, if a new person enrolls in your class, you're not screwed. You can always just put them at the end of the class. So at the end of it, we have a big list of scores. If you read through the rest of the homework, you know that the score is composed of an e-value and a bit score. But you want to look at both in this example. Also, the rest of the code in the assignment assumes that it's in this format. So just use this function for this hard part. The other two functions you have to make should be a little bit easier, but I can go through it in office hours too. Just watch the videos on functions if that helps. Otherwise, I'll be in office hours. But at the end of a function, you always just return what you did. So that's return is the keyword there. Okay, yes?
So the scores variable will have both the e-values, so it's going to be like 2D.
Yeah.
So when you sort it, like, which one does it sort?
It always sorts by the first element if there's multiple elements. So it sorts it by e-value. It's not, I don't think this is kind of the most intuitive way to represent this type of data, but the rest of the assignment assumes that your list of scores is in an e-value and a bit score in the same list. So, yeah, this set of code will output the code you need for the rest of the assignment. Okay, we have about 15 minutes left. Any other questions on the homework? I have it in front of me now. Did you want to go through this slower? I'm getting a lot of no's, so that's fine. Anything about the exam, I guess, we can talk about now?
What was the average?
It was like high 80s or something. I don't know. I'll look later. Okay. Well, I'm gonna cut off the video. I'll be around for the next.